All right, this is number 24 from section 7.3, and it's a linear programming problem with the graphing, two variables. And this is one of the ones with the investments. So you got two funds, the John Hancock 3 Disciplined Value Mid-Cap A Fund, selling at $15 a share, 3-year average return of $2 a share with a risk measure standard deviation of 17.6. And then you've got the Highmark Geneva Small Cap Fund, selling at $36 a share, 3-year average return of $6 a share, risk measure 16.7. So Sandy Grady wants to spend no more than $6,000 investing, but she wants to get at least $600 in annual revenue, and she wants to minimize her risk while doing those things. So what should she buy? There's a couple examples in the book. There's one at least that shows how to handle that risk measure. But basically, if you're not totally sure what all those words mean, it's not too hard to deal with them. Basically, you can take those standard deviations for each fund and just kind of add them together this way. So the standard deviation for the X fund, the John Hancock, times X, the number of shares, and the standard deviation for the Y fund times Y, the number of shares. That's like her total risk that she wants to minimize. So that's your objective function there. That's what we're minimizing. And then we just need to read through the rest of that stuff again and make our constraints, graph it, and test those core points. So if you look, it said she has $6,000 to invest, so no more than $6,000. So we got to be less than or equal to $6,000. And you got to look at what she's going to spend, right? So it says that the John Hancock, that X one, sells at $15 a share. So that's going to be 15X. It says that the Highmark Geneva, the Y one, sells at $36 a share. So plus 36Y is less than or equal to that 6,000 value. And then the return is the other thing. You get a $2 return on the John Hancock. You get a $6 return per share on the Geneva. And she wants to get at least $600 return in annual revenue. So greater than or equal to 600. And again, these numbers were $2 for the X and $6 for the Y. And so there's that, right? Those are the two main constraints here. The rest is just, we've got the two kind of typical constraints where, she can't buy a negative number of shares. And, stocks and investments are weird. And, maybe you actually kind of can, because there are ways to like short sell things that you don't actually have. But this problem isn't that complicated. So we're working in the first quadrant, as we tend to do with these types of problems. And we're going to graph this. So set this up. And if you just kind of do the intercepts method, if you look like 2x equals 600, you'll get x equals 300. So here, I'll just plot that over here. And again, the graphs don't have to be perfect, right? You just kind of need to know where things are crossing each other. So good enough is what we're looking for here. 6y equals 600. If x equals 0, then y is going to be 100. So we'll put that there. There's one of our lines. Okay, this is for the returns. I'll just call this, this was cost. So we'll just call this cost and then return. So here, R for return. And then here, cost in purple. So for the cost, 15x equals 6,000. If you divide by 15, you get 60 divided by 15 is 4, so 400. So x will be 400 when y is 0 on that one. So that'll be out here. And 36y equals 600. If you divide by 6, you get 6y equals, 100 here. And so a sixth of 100 is, 1.6 repeating. And so 166, I think, is what we're looking at. So, is that right? 36. 3.6. Yeah. So I think we're looking at about here at 166.6 repeating, if I'm not mistaken. And so you check with the calculator, of course. Get that line, and that's going to be the cost line. And yeah, if you look at both of these, y is on the less than side on that one, so we're going to be shading under the purple line. Y is on the greater than side on that one, so we're going to be shading above the red line. And again, we're staying in the first quadrant, so to the left of the y-axis, I'm sorry, to the right of the y-axis, and then above the x-axis. So right in here, this is our region. And so we have those 4 corner points, and those are them. There's no intersection to find, which makes this one a little bit easier. We actually know all the corner points already. 0, and then, this is basically 100 over 6, or no, this is 600 over 36, which is 1,000 over 6, I think. Yeah. So we could write it that way, or 500 over 3, or 166.6 repeating, whatever. This is 400, 0. This point is 300, 0. And this point is 0, 100. And I would definitely use a calculator for this next part. Let's see if I can get it pulled up here real quick. So corner points and our z value, which of course is defined up here. And we're just going to plug those into that function. Let's see if I can get the calculator over here really quick. All right. And so if I plug that z function in, you know what? Yeah, we'll just do it right here. We'll just do 17.6 times. And for one of the corner points, it's going to be 0, 100, right? So 0, 100. And we could probably do this one in our heads. I'm just kind of setting it up, though, so I can reuse the same line of text in the calculator and just change things. So that's why I'm bothering to put the 17.6 times 0. And that just gives me 1670 is the risk there. And we've got 0 and then 1,000 over, right? And so if we hit second enter, we can change that 100 to a 1,000 over 6. And so that's going to be 2783.33. And again, this is a measure of risk. So, I don't know, what does that mean? It's not really a dollar amount. Or I don't know, maybe it kind of is. It's a standard deviation thing. But I wouldn't worry about units here. Just, we're trying to get the lowest value. And we don't need to be super precise. We just need to know which one's the lowest. 300, 0 and 400, 0. So I guess, we really didn't need to have the code with everything in there because they all have 0 for one variable. So it's going to be just 300 times the 17.6. And then what is it, 400 for the other one? 400 times the 17.6. And those should give us our other two values. So we got 5280 and 7040. And so those are definitely a lot more risk. 5280 and 400, 0. My work's not super neat here, but 7040. And so our final result is that minimum risk is going to be right here. She can achieve her goals, get the return she wants if she buys 100 shares of the Highmark, and that's it. And that gives her a minimum risk of 1670. What was her name? Sandy? Sandy will minimize risk to 1670 by investing in 100 shares of Highmark and none of the John Hancock.